Hey, welcome to Learning with Lou. Today we're going to talk about comparing decimals using place value and how to identify equivalent decimals. So just a very quick refresher, because we're going to be focusing heavily on decimal place value, you do have to know that to the left of your decimal point, you have your regular place value, ones, and then it would just continue, tens, hundreds, thousands, and so on. If you go to the right of the decimal point, you have tenths, hundredths, and thousandths, and each place to the right is actually smaller and smaller and smaller. So that's just something important to keep in mind. When you compare decimals using place value, it's just like comparing whole numbers. I always say start all the way to the left. That's going to be your largest place value. So if you take a look here, we're comparing 1 and 62 hundredths to 1 and 68 hundredths. And we started all the way to our left. Our largest place value in this number happens to be the ones place. So I have a 1 and a 1 in my ones place. So far, I can't compare these yet because it's the same number. I have to go one place value over to the right. So now if you see here, I went over from my 1 to the 6 in the tens place. So 6 in the tens place, 6 in the tens place. I still can't compare these just yet because it's the same digit. Now I go over to my hundredths place, which is one place value over to the right of the tenths. So I go from my 6 to my 2. I have a 2 in this hundredths place and an 8 in this hundredths place. Now all you do is ask yourself, what's greater, 2 or 8? And you open up your symbol towards the greater number. I always like to think of it as either I tell my students Pac-Man, or think about it like the alligator mouth. Whatever it is, you want to open it towards the bigger number. It wants to eat the greater amount. So 1 and 62 hundredths is less than 1 and 68 hundredths. One quick thing I want to address, because I see this happen all the time in my classroom. A lot of students will do this because they see the decimal point and they kind of forget about regular place value. They'll say, okay, I have a 2 over here all the way to the left and 8 in this number all the way to the left. And then they'll say, well, 8's greater than 2, so it must open up this way. But you have to remember, regular place value still matters with your decimals. This is really a 2 in the tens place. So this is really like comparing 20 to just an 8 in the ones place, which is 8. So obviously 20 is larger than 8. I always tell my students to do this instead. When you have two-digit numbers to the left of your decimal point, just underline the whole thing. You have 24 compared to 8. What's greater? Well, obviously 24 is much larger than 8, so 24 and 16 hundredths is going to be larger than 8 and 42 hundredths. Another mistake that I see very common is students will think that whichever decimal place has more digits in it, it is automatically larger. Remember, this is not just like regular place value. Decimal place is a little bit different because here we have an 8 in our tens place and a 5 in our tens place. So these are two different numbers in the tens place that we're comparing. None of these matter anymore. We have two different digits, 8 and 5. This is all we're worried about. Since 8 is greater than 5, and 8 in the tens place is greater than 5 in the tens place, 2 and 8 tenths is greater than this giant decimal here. You don't even have to worry about everything else. So just because one number has more digits in it doesn't automatically make it a bigger number when you're dealing with decimals. One final thing before I have you try some practice problem on your own is equivalent decimals. Now, just like fractions, decimals can be equivalent to each other. That means even though two decimals have different place values, they can be equal to each other. For example, you have 3 tenths and 30 hundredths. If you were to fill these out in visuals like you see here, 3 tenths, because we have 10 total parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, compared to hundredths, because we have 100 little squares here, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, they actually take up the same amount of space. They're equivalent to each other. So we have a 3 in the tens place and a 3 in the tens place. It doesn't matter how many more zeros come after it. You could have thousandths, and it's still the same. 3 out of 10 would still be the same as 300 out of 1,000 or 30 out of 100. It doesn't matter how many zeros you add on. If there's no other digit all the way to the right, if it's just zeros all the way down, it's going to be equivalent because we still have this same number in our tens place. And just one more example here, you can see that 7 tenths is the same as 70 hundredths. 7 out of 10 is the same as 70 out of 100. When you add a 0 at the end, all you do is just make more equal parts. Think about it like a pizza. If you had a pizza cut into 10 slices and you ate 3 of them, you had 3 out of 10. Now, that same size pizza, if you were to cut it into 100 very, very, very tiny slices and you ate 30 out of 100, you might think to yourself, well, 30 slices sounds like more, but remember, if it's the same size pizza cut into 100 slices, you're gonna have very, very, very tiny slices like here, and you would be eating actually the same amount. And if you've watched my fractions video, this could really help you out a lot because decimals and fractions are very related to each other. Alright, we have some examples here. How about you go ahead and pause this video and see how you could do on your own, and then in a couple seconds you could unpause it and I'll show you the answers. Okay, so if you take a look here, I showed you the correct symbol and I underlined the place value that tells you why it's correct. So in the first one, we have 1 and 29 hundredths compared to 1 and 17 hundredths. Now 1 and 29 hundredths is greater because we have a 2 in the tens place compared to a 1 in the tens place. Since 2 is greater than 1, that makes 1 and 29 hundredths greater. Down here, we compared the ones place. We have a 4 compared to a 2 in the ones place. So that means none of these even matter. We're just comparing the ones place. 4 is greater than 2, so that makes 4 and 56 hundredths greater. Down here, we have 38 hundredths is less than 39 hundredths, and you can see because of our hundredths place. 9 is greater than 8. Over here, 5 and 4 tenths is less than 5 and 9 tenths due to the tenths place. 9 is greater than 4. Over here was a little bit tricky because you had two different amounts of place values, but what you could do is you can make them have the same amount of place values by just adding a 0. So, this number didn't have a hundredths place. I just put a 0 there because it's technically equivalent, as we saw earlier in the video. So we have a 0 compared to an 8. 8 is greater than 0, so 1 and 9 tenths, or 1 and 90 hundredths, is less than 1 and 98 hundredths. And finally, down here we had, if you wanted to do the same trick, you could, but it doesn't really matter because you stopped right at your tenths place. 3 is greater than 2, so 7 and 32 hundredths is greater than 7 and 2 tenths. And that's all we got for today's video. If you feel like this video helped you, please do me a favor and hit that like and subscribe button. It really helps me out. And comment if there's any topics you want to see covered in the future. As always, I'd like to let you know if you want access to any of these resources you see, you could check the description below and access my shop where I sell all of my lesson plans, these resources, helpful anchor charts, all of these tools for you to use in your classroom or at home. Thank you again for watching and never stop learning.